So we're going to look at solving linear systems using substitution. So a linear system is where two lines intersect. So what we need to recognize is that this is a line, so it can be written in the form of like y equals mx plus b, and same with the other one. We can rearrange these. They're not even really in any type of form. This is considered your slope y-intercept form. Another form you could write a line in is standard form, which is y equals ax plus by equals 0, not equals 0, it would be c, sorry. Did they talk about these different forms with you guys or anything? No? Okay, not really important. It's in no special form right now. But in order to do substitution, what we do need to do is we need to set at least one of the equations equal to a variable. So you have a y and an x in this equation, and an x and a y in this equation. So we're going to have to choose one of them to set equal to. We're going to number them just so it's easier to refer to these. So I'm going to call this one equation 1 and this one equation 2. What variable would you like to set it equal to? First of all, which equation do you want to work with to start? It doesn't matter.
2.
Okay, we'll work with equation 2. And which variable would you like to set it equal to?
2y.
Okay, so we'll set it out just to the y, actually. We don't need the coefficient. So what we're going to do is rearrange equation number 2. So we take equation 2, and let's start rearranging. So it starts with 3x plus 2y equals negative 8. Great. The goal, like we said, isolate for y. So the very next step is, is to move our 3x to the other side. When you move it to the other side, it's going to be a negative 3x. So the equation will now look like this. 2y is equal to negative 8 minus 3x. Great. Still, the goal is to isolate for y. So we need to move this 2 to the other side of the equation. Well, this is 2 times y. So in order to move it to the other side of the equation, both terms on this side have to actually get divided by 2. So our next step will look something like this. Y, because we've already moved the 2, is equal to negative 8 over 2 minus 3 over 2x. Or 3x over 2, it's actually the exact same thing. Let's shrink this so we have a little more room. There you go. Okay, so now that we've done that, let's simplify this equation. Bring it over here. Y is equal to negative 8 over 2 is negative 4. And we can't really reduce this fraction, so it's going to stay as negative 3 over 2x. And I'm just going to rearrange it. Y equals negative 3 over 2x minus 4. I just changed the order of them. And the reason I did this is to relate it back to our y equals mx plus b. That's it. It's just a form of very similar, not similar with, what's the word? Used to, I guess. So we can easily find the slope. We know the slope is negative 3 over 2, and we can find the y-intercept. It's negative 4. Wonderful. So now that we've done that, which was quite a bit of work, just for the very first step, we're going to now take this equation, okay, and substitute it into y in the other equation. So remember we originally worked with equation number 2. Okay, we're going to take equation number 1. Bring equation 1 over here. Equation 1 was written as 5y minus 4x equals 3. Great. Well, what did we say our new value was for y? So we're going to take y here, and we're going to replace y with what we had down here. Okay? So we have to replace all of y. Everything else in the equation is going to stay the same. So we have 5. That is a terrible 5. Let's try that again. So we had 5, and then we replace y with negative 3 over 2x minus 4, okay? So remember, I just replaced that one part. The rest of the equation, minus 4x equals 3. And if you notice, pretty much everything's the same. The 5 and the 5 are there. The negative 4x, and equals 3, they're there. The only big difference is we replaced y with what y was equal to in this equation over here, okay? Now we simplify. The reason we've done this is because now there's just an x. So we can now isolate for x and get a value for x. So I'm going to have to use my distributive property here. So 5 times negative 3 over 2, that's going to give me negative the best way to describe that is you can turn this into a fraction, 5 over 1. And you multiply tops of the fractions by each other and then the bottom. So 5 times negative 3 is negative 15, and 2 times 1 is 2x. 5 times negative 4 is negative 20, and we have negative 4x equals 3. Great. So we do have a fraction here, but that's fine. We're going to put together, it's red. So these are like terms, our x's, or our variable terms with coefficients, and then our constant terms. We're going to put those together. So I'm going to get them all on the same side of the equation, okay? So I'm going to move this negative 20 to the other side, but I'm going to leave everything else. We have negative 15 over 2x minus 4x is equal to 3. Now it's hard to see. That was a negative 20, so when it moves to this side, it'll actually be, yes, good, positive 20. So the right side of the equation is going to be simple. 3 plus 20, 23. Great. This is a little harder. When you add or subtract fractions, they have to have the same denominator. So right now the denominator is 1. So I'm actually going to have to multiply both the top and bottom value by 2, so we get a denominator of 2. So I'm going to get negative 15x over 2 minus 8x over 2 is equal to 23. I'm going to see if I can shrink this new stuff I did. Oh good, I can shrink all that again. It's getting a bit small. Let's move this over here. So negative 15 minus 8 is going to be negative 23. So we get negative 23 over 2x is equal to 23. This is why this works out nicely. Remember, still the goal, I guess a bit convoluted this one, isolate for x. The fastest way to do this is, let's move the 2 first. Oops, that's not what I wanted. I could have swore there it is. Thank you. Let's move the 2 over first. So to move the 2, because it's division over here, it's going to become multiplied by 2 over here. So we're going to end up with still negative 23x on the left. And 2 times 23 is going to be 46. And now finally we're isolating for x, so we're going to divide both sides by negative 23. And x is equal to, it's actually going to be, it's a positive divided by a negative, so it'll be a negative answer, and it's, actually the answer is 2. So x is 2. So we'll put that up here. X equals negative 2. We got 1. A lot of work just for x. The next part's pretty simple, actually. Because now we have a x value, we can plug this x into either equation 1 or equation 2 and get the exact same answer, okay? Is there anyone you want to work with specifically? Let's just choose equation 1. Okay, so equation 1 again was 5y minus 4x equals 3. And again, because we have a value for x, there we go. Because we have a value for x, we're going to replace the x in this equation with the value of negative 2. So we rewrite it. 5y minus 4 times negative 2 equals 3. 5y, negative 4 times negative 2 is positive 8 equals 3. We move the 8 to the other side, it becomes negative 8. So we have 5y is equal to negative 5. And then when we move this 5 over, same idea, divide both sides by 5. Y equals negative 1. So our answer should be x equals negative 2, y equals negative 1. Let's test this and find out. Let's go into Desmos here. And let's put in the 2 equations. I don't remember them off the top of my head. So 5y negative 4x equals 3. Let's try that one first. 5y negative 4x
equals 3.
Thank you. And then the second one, I think, is 3x. I'm not going to try from memory. 3x plus 2y equals negative 8. Okay? 3x plus 2y equals negative 8. Here we go. Let's zoom in. Whoa. That's better. Where do they intersect? -2, -1. Uh-oh, did we make a mistake? Oh, no, we got it right. Okay, -2, -1. Good, I couldn't remember our answer. Great, we got it. Okay. Okay, and that's that.